The concept of the paradox of time refers to various philosophical, scientific, and logical dilemmas that arise when contemplating the nature of time, particularly in relation to issues such as causality, determinism, and the arrow of time. These paradoxes challenge our intuitive understanding of time and have intrigued thinkers for centuries. Here, I'll outline some notable examples. The grandfather paradox. This is one of the most famous time paradoxes. It involves a hypothetical scenario where a person travels back in time and kills their own grandfather before the traveler's parent is conceived. This raises the question, if the traveler's grandfather was killed before the parent was born, how could the traveler exist to travel back in time in the first place? The paradox highlights potential inconsistencies in the concept of time travel and the possibility of altering the past. The bootstrap paradox, also known as the ontological paradox, this scenario involves an object or information that is sent back in time and becomes its own origin. For example, imagine a composer travels back in time and gives a famous musician sheet music for a masterpiece. The musician then publishes the piece, and it becomes famous. In the future, the composer learns the piece and travels back in time to give it to the musician. The paradox arises because the piece of music has no clear origin, it seems to exist without being created, violating traditional notions of causality. The twin paradox. In relativistic physics, the twin paradox arises from the different experiences of twins when one of them travels through space at a high velocity, near the speed of light, while the other stays on Earth. According to special relativity, time dilation occurs for the traveling twin, meaning that his age more slowly relative to the twin who stays on Earth. When the traveling twin returns, he finds that his earthbound twin has aged more. This apparent contradiction challenges our intuitive understanding of time as an absolute and universal quantity. The arrow of time. This paradox concerns the asymmetry of time, particularly the apparent irreversibility of certain processes. While the fundamental laws of physics are time-symmetric at the microscopic level, macroscopic phenomena exhibit a clear directionality or arrow of time, characterized by the increase of entropy, the measure of disorder, over time. This raises questions about why time appears to flow in one direction, from past to future, despite the underlying time symmetry of physical laws. The predestination paradox. This paradox arises when events in the past are influenced by knowledge of future events, leading to a circular causal loop. For example, imagine a person receives information from the future and acts on it, which then leads to the future outcome that provided the information in the first place. This raises questions about free will, determinism, and the possibility of changing the course of events. These paradoxes highlight the complexities and mysteries surrounding the nature of time, causality, and the universe. They provoke thought-provoking discussions among philosophers, scientists, and science fiction enthusiasts, pushing the boundaries of our understanding and challenging conventional notions of reality.